It's time for Vad är klockan? A secure way to find out what time it is. With Christer Weinigel at Netnod. Welcome.
Thanks. So, how do I do this? Nope. So, hi everybody. My name is Christer Weinigel. I work for Netnod, and this is a project called Vad är klockan, which is Swedish for what time is it? And it's, as you said, it's a secure way to find out what time it is. So let's start with, why is accurate time important? Well, many security critical protocols nowadays, they need time. Usually it's only within a few minutes or hours. DNSSEC, which is used for secure domain name lookup. So when you ask for google.com, you get an IP address back, and that's DNS, and DNSSEC adds security to this. But DNSSEC needs time to within a few minutes to really work well and be able to validate these. There's something called TLS, SSL, uses X509 certificates. And to validate a certificate, you need time. And TLS is then used by just about every protocol on the internet, which is security. So HTTPS, which is the basis for secure web, it uses TLS. If you want secure mail, SMTPS, IMAPS, POP3S, all of those use TLS. What's the risk then? Well, if you don't have accurate time, somebody might trick you into using old information. For example, if you have a TLS certificate from 5 years ago, that might have been issued with algorithms that are weak today. Algorithms that if you have $100,000, you can buy enough compute time on Amazon to crack the algorithms and then impersonate whoever that certificate belongs to. There's also always a risk of information leaking. The more time passes by, the bigger the risk is that a backup tape, a hard drive, will end up in the wrong place, so that information you might have had might have leaked. By saying, well, this certificate isn't valid for longer than a year, you can minimize the exposure from an information leak. And then, last but not least, the application itself might need time. For example, if you have a public building like this, or semi-public building, you might have a door controller which opens the door at 9 o'clock. And then you make sure that there are always people in the building at 9 o'clock. If you can trick that little computer controlling the door into opening the door at 7 o'clock in the morning, then you might have a bit of a problem. So how do you keep time? Well, if you have a computer that's running, that's no problem. If you just manage to set time somehow, it can keep track of. You have interrupts, 100 interrupts per second, so you just say that, well, every 100 interrupts you increase the seconds by 1, no problem. But then you have a device like this one, the one shown on the screen. It doesn't really have time. It doesn't have a battery, so it doesn't keep time when it's turned off. If you have a Raspberry Pi, and I guess most people have played around with those, well, a Raspberry Pi doesn't come with a battery. If you want a battery to keep time when it's off, well, then you need to buy a small battery hat, and most people don't do that. There's also something called shipping mode, where even if you do have a battery, it's usually not turned on until the first time you power on the device. This is to save battery while it's on a shelf in a store or something like that. And then there's also something called the 10-year on the shelf problem. Basically, if you have a device which has a long lifespan, they might be sitting on a shelf in a store for 10 years. So when you take it off the shelf, well, everything is outdated in the device. And so even if you hard-code the certificates, for example, well, they might be old. So that's a bit of a problem that you want to solve. So how do you get time then? Well, there's good old NTP. This protocol is fairly old. It was the first incarnation, I think, is from 1984. And back then, everybody trusted everybody. There was something like 10 computers on the internet, all talking to each other. Everybody knew who ran the other computers. So NTP has no security. There have been attempts to add security, didn't go that well. But 2 years ago, or 2 or 3 years ago, people started working on something called NTS, and Netnod have been involved in the development of this protocol. It adds security to NTS or to NTP. So it's basically NTP with security extensions, but it also relies on TLS and also DNSSEC if you want secure name lookups, which is a bit of a problem because TLSSEC and DNSSEC require time to work well. So you have a bit of a bootstrapping problem. The idea is that can you really lift yourself by your own bootstraps? So you have the chicken and egg problem. You need time to validate a certificate, and you need a certificate to validate that the time you get is secure, or to secure the time questions. Another small problem with TLS is that, well, once again, this small device, it's resource constrained. It doesn't have that much memory. It doesn't have that much flash. This device can run TLS, but you'll use up most of the memory in it for TLS and won't have space for your application. And that's not a trade-off many people are willing to do. There's another issue with using NTS, which is what do you do if the server you're talking to gets compromised? If somebody can get into that machine, if they can steal the certificates from that machine, or if it just breaks, the clock starts giving the wrong time. So we want a solution to this. So what are our goals then? We want something that can bootstrap time without relying too much on other protocols. So it shouldn't rely on already having time. It shouldn't really rely on a single server. And it should preferably work on small resource-constrained devices. And so what we set up for this project was to basically say, we want to create a small library which is portable to many platforms, Linux, FreeRTOS, Zephyr, whatever, Arduino. It should be easy to use and, quite important, easy to use correctly. Because, for example, I've been working quite a lot with OpenSSL, and OpenSSL has a few gotchas. There are mistakes that everybody make when they start using OpenSSL. So we'd like to avoid those kinds of errors. And we want to write something which has example code documentation. One possible solution for the sort of all the protocol things is a protocol called Roughtime. It's an IETF draft. It's written by Anjal Malhotra, and I think she studied at MIT when she did this. And she started this a few years ago, and then other people have kept working on it. Yeah. So it uses certificates, but they're not X509 certificates. They're just similar. But it's basically public keys, private keys, using ED25519 as the algorithm. And the idea is basically a client asks multiple servers for time. And if you ask multiple servers, if a majority of them can agree on something, you have a consensus, well, the client says, I get enough answers that are the same, I'll trust this answer, I'll use it. That's the way to protect against a single server that is failing. And hopefully, this also solves the sort of 10 years on the shelf problem by saying, in 10 years, enough of the servers that you are talking to will still be running so that you can actually get something to work. And one idea is also, this is the list of servers is hard-coded in the firmware, so basically, when you upgrade the firmware, you get a new list, and you should be able to upgrade the firmware. All of these principles can be used with other protocols, but we chose Roughtime just because it's out there, people are working on it. What are our results then? Well, we have written a C and Python implementation of Roughtime, a client side. It runs on Linux, Arduino, ESP32. It's all available on GitHub if you wanted to start looking at it. I still have some fixes to make, but we're working on it and we'd like contributors. Documentation is available on ReaderDocs. Netnod has set up 2 Roughtime servers that we intend to keep running as long as people are interested in Roughtime. And there are also other Roughtime servers. For example, Marcus Dansaria has been working on the protocol. He runs Roughtime.sc, and we're actually using his implementation. Future adoption, please get involved. We want people to start using this. We'd like to make Roughtime a proper RFC, so it's a standard. Right now it's a draft, and the draft has made some incompatible changes. So we hope this will stabilize the coming year. We'd also like more Roughtime servers, more people, because Netnod are planning to run 8 servers. We want more people to get involved, have more servers out there. And then the people involved is me, Weinigel at Netnod. Please contact me if you have any questions. We also have Kalle Lindqvist and Filip Eriksson, 2 students at Örebro Universitet who's been working on this over the summer. That's all. Thank you very much.